Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us move to the next question, question number 32. Let us start the next question, question number 32. A wheel of radius r, this is a wheel of radius r and mass m, this mass is m, is placed at the bottom of a fixed step. This is a step, here the bottom of the fixed step is placed here of height r. This height is also r, as shown in figure. Constant force is continuously applied. There is a constant force which is continuously applied on the surface of the wheel. On the surface of the wheel, a constant force is applied. Where it is applied, not given. So that it just climbs the step without slipping. Consider the torque tau about an axis normal to the plane of the paper passing through the point Q. So the axis is considered here. Axis is considered here normal to this, just like that. Which of the following options are correct? So there is an ambiguity in the question that the torque that is asking is, consider the torque about an axis. Which torque? Whether this is net torque due to the weight and the force applied, or only due to the force applied. So because of that ambiguity, we will consider only torque due to applied force. So this is our assumption, because you can assume the torque due to this and also due to the weight. Consider the torque tau about an axis normal to this plane. So we'll consider the torque only due to the applied force, so that it climbs down, whatever it is case. Now option 1, if the force is applied at a point P, so this is the situation. There are a few situations. This is our center. This point is P, this point is S, this point is Q, this point is X, any point, and this distance is R. Option number 1, if the force is applied at point P, here the force is applied at point P, as shown in figure, tangentially, so obviously I will apply like this, because I want to rotate like that so that it can climb up. So the force is applied like this. This force is constant in magnitude. Then torque decreases continuously as the wheel climbs. So to find the torque due to this force, if I consider torque due to this force about this point Q, so torque about the point Q due to this force at P is force into perpendicular distance, and the perpendicular distance is this length, that is 2r. This is the torque. This is the line of action of the force. This is the perpendicular distance. So F is constant, because it says that F is constant. This is constant. 2 is also constant, R is also constant. So it is a constant value. Because as it turns to another position, the wheel turns to another position, the same tangential force is applied. That constant force is applied in any other situation. that the same constant, because this will remain the same. This will remain the same. 2r will remain the same. So the torque will remain constant, but it says that the torque decreases. But here the torque is constant. So the option number 1 is not right. It is a constant torque. It will not decrease. Second option, if the force is applied normal to the circumference at point x. At point x, the force is applied normal to the circumference and torque is constant. Then torque is constant. Let us solve that also. I have wheel like this, and this is a point P, this is a point S, and this point Q, and there is a point here X. Now normally the force is applied, so it will be like that only. This is the force applied at this. Suppose this makes an angle theta with this. If this makes an angle theta, I will see that this one here. Suppose I will take it makes an angle theta here. So in this direction, this is the force direction, and this is the point Q about which you want to find the torque at this situation. This is for option number 2. Then this is the line of action of the force, and this is the perpendicular distance. This is the perpendicular distance. This is your R perpendicular. So torque is this force in R perpendicular. Force is F, R perpendicular this distance. This is our R. This is theta. So this is R cos theta. This is R sin theta. Perpendicular distance is R sin theta. That means when I apply a force, I can see that as the wheel rotates, this theta will change, because as this rotates, the theta will change, and this theta changes, sin theta will also change. Sin theta changes, then this torque will also change. So here the torque is not constant. It will change. This is variable. Depends on theta. Here it says that torque is constant, but here the torque is not constant. It's changing with theta. So this is also variable. Torque is not constant. It's variable. So this option is also wrong. Let us see the third option. The third option says if the force is applied normal to the circumference at point P, then torque is 0. So what is the situation? The situation is like this. This is point Q, this is a S, this point is P, this point is X. Now the force is applied normal to the circumference. What is the question? The force is applied normal to the circumference at P. So at P, the force is applied normal to circumference. Normal is what direction? This is the normal. So in this direction force is applied. Then it says that the torque is 0. Torque about Q in this situation is 0. This is given. Let us check whether this is right or not. This line of action of the force passes through the point of rotation, because we know that for any object We know that if I want to rotate this rod about this hinge, if I apply force, then it will rotate like that. But if I apply force in this direction, this will not rotate, because this line of action of the force is passing through the point of rotation. If I apply force in this direction, then also it will not rotate, because it's passing through the point of rotation. When line of action of force passes through the point of rotation, it will not rotate. So torque in this situation is 0 for this case and this case. Similarly, the force that I am applying here is passing through the point of rotation, so it will not rotate. So therefore, the torque about Q is 0. So that is correct. This option is correct. Option number 3 is correct. There is no doubt about that. This is correct. Fourth option we'll choose. What is that fourth option? We'll see. Option number 4, that if the force is applied tangentially at point S, if a force is applied tangentially at point S and then torque is not 0, but the wheel never climbs the step, what is the situation? This is the point S, this is the point P, this is the point Q, this is any point X. Now the question is, at S the force is tangential at S, then torque is not 0, this is given, but the wheel never climbs the step, never climbs. Torque is not 0, that means there exists a torque, but then it will never climb. If I see that, then this is the line of action of the force and this is the perpendicular distance. This distance is same as this distance, which is r. So the torque is Fr. Where F is constant force, R is constant. So this is a constant and not 0. Obviously it's not 0, this part is correct. It will never climb, that is not correct, because if the force is sufficient, then it will climb up. Sufficient, then it will climb up. This option is wrong. Never climbs, but will never climb, that is wrong. If the force is very, very large, it will climb. So the option number 2 is the only correct option. This that we have discussed so far, we have considered only torque due to the applied force F. We have not taken into consideration the force due to the gravitational force acting on the wheel, because that is not sure which force is talking about. A constant force is continuously applied on the surface of the wheel so that it climbs. Constant force talks about the force only that makes possible to climb. Consider torque tau about the axis. So which torque? That I have considered the force, only this force, applied force and torque due to that. If you consider another force, that is the gravitational force mg, then the situation will be something else that you may check out, but that is not sure whether that is the question. Okay, so the answer to this question, when this is considered only, then option 3 is correct. Okay, thank you.